here's how to do datum axis point drilling in NX. So by the name, you may not quite understand exactly what this is, but datum axis point drilling is basically what the name is. You're going to create a datum axis and you're going to create a point, and you are going to drill that point on that datum axis. In NX, you do not need to have an actual hole in order to drill a hole. So if we look at our part here, we have this pocket with this tapered box in the center of it. So we look at this, and maybe this is hard metal, and we need to have a start hole, because ramping down to the bottom of this pocket here to high-speed machine it out, it might tear up the bottom of our tool, which we don't want. So not having a hole, but we need to drill a start hole. So the way that we can do this is with datum axis point drilling. So we can go ahead and say application modeling, and then what we're going to do is we're going to do a curve. We're going to create a point. Now we're going to toggle down and we're going to go to point on face. So what I'm going to do is I'm going to drop a point right here on that face, and that's going to be my start hole location. I'm going to go ahead and say OK. Now you can see that we have a point there, and it also built that point over in our modeling tree. So now if I go to Menu, Insert, Datum, Datum Axis, now this is only accessible in the modeling function. I can click Inferred, and what I can do is I can click this point, and then I can click the face, and it's going to give me a datum axis on that point, or a vector. I can then say OK, and once again it will build that in my modeling tree. So now that I have a point and a datum axis, I basically have a location to drill and an axis to drill on. I can go back to Application, Manufacturing, and then I'm going to go to Tools. And what I'm going to do is I am going to say Move Object, and I'm going to select that point, and I'm going to choose the distance function. It's going to ask me to specify a vector. I'm going to click that datum axis that I just created, and I'm going to push this point up, let's say 100 thousandths of an inch. Make sure I'm on copy, and I'm going to say OK, and now you can see that I have 2 points here. Now, since this point here that I just made is a copy of a point, it's going to be located in non-timestamp geometry right here, just for your reference. So now that I have my datum axis and my points, I'm going to go ahead and drill this hole. So I'm in Manufacturing, I'm going to go to Home, and I'm going to create a tool. I'll grab a tool from my library here. That's just going to be a, let's go with a 1/4 inch drill. Right here, we'll go ahead and just say OK, cancel. I have my 1/4 inch drill here. I'm going to grab and drag this guy out because I don't want it in my right angle head. So here is my drill. So what I'm going to do, go to my program, and we're going to go ahead to create operation, drop down to hole making to do a drilling toolpath. I'm going to pick my first drilling operation. We'll throw this in my op1 program, and we will select this 1/4 inch drill. Say OK. Now, when we go to our specify feature geometry for drilling, I can actually click that point that we copied, and that is what I'm going to drill. Now, if you look at this, you can see that the z-axis is the same as our MCS. So is our y and our x. We're going to drill this hole from the side, so that clearly isn't going to work. That's where the datum axis comes in. We can select specify orientation, select this z leg, and then select our datum axis, and it's now going to snap the z-axis of this drilling toolpath to that datum axis for our point. So we can go ahead and say OK right there. That looks good. Now, the reason I moved that point up 100 thousandths is because of the drilling depth. You have to give your drill a depth to go to. Even if it's only 1/10 of an inch, it must have a depth. So I can go ahead and unlock this guy for my depth, and I'm gonna go ahead and put 75 thousandths here. That way I am staying 25 thousandths off the floor with my rough start hole drilling toolpath, and I'm as close as I can pretty much comfortably be while still roughing the hole in and not being in a finishing state. So I'll go ahead and say okay, and then we'll just leave this alone. We'll assume it's a carbide drill and it can go in single pass. We'll go ahead and generate, and now you can see that there is a toolpath created there. Now looking at this, if we verify and replay, you can see in the traversal motion, which is your dashed blue line, it's going to rapid to that location right there, which is inside the part. We clearly don't want that because that's going to crash the machine. So we'll go back into our spot drilling operation, into our cutting parameters, and we'll go ahead and extend this up an inch instead of 1/8 of an inch. And we'll say okay, generate that. Now you can see that where we're feeding from, that blue and white dashed line is above the part. So we can verify now, replay, and now it's going to rapid to that location, drill our hole down within 25 thousandths of the floor, being the floor point is 0, and this point here being 100. And then our next step is going to be retract up above, and then traversal out to our clearance plane. And now you've drilled a start hole in your part. So if we go back to verify, to our dynamic, we can one step. I haven't faced this off yet, so I still do have a rapid collision there, but that's okay for this example. We'll go ahead and say continue. We can step this through, drill, out, clearance plane, and there you go. You have a start hole that maybe you can drop into now for your next toolpath or your rough machining or whatever you might need, but you did not have to have a hole on the part to do so.